In this next example, I've got something here that's a little bit different than the previous ones. Now, from the outset, generally what students will do is they will start factoring the denominator and then apply the process of partial fraction decomposition. Now, the thing you need to pay attention to is that the numerator happens to have a higher degree than the denominator. So this is an improper rational, okay? So everything we've been based off of, all the results that we had, were for proper rationals. So how do we handle an improper rational? Well, you can always change an improper rational into the sum of a polynomial and a proper rational using polynomial division. So that's one solution. We could just get started with some polynomial division, and I'll walk you through it in case you've forgotten the process. It's pretty straightforward, but it's easy to get lost in it. All right, so I'm just going to take the denominator that goes on the outside of my long division bar, and the numerator goes underneath. Now, I just start with the first term, and I ask myself, what do I need to multiply this by to get exactly 2x cubed? Well, that is 2x, not just x. Sorry about that. Okay, so 2x times 2x squared would give me 2x cubed. 2x times negative 3x would be negative 6x squared. 2x times negative 4 would be negative 8x. Now, it's not imperative, but it is a good idea that if there happens to be any missing degrees, like descending degree powers here, you want to pad those in with like 0 times x squared if necessary. It's not the end of the world if you don't, but it's a good idea, just to keep things lined up. When we go through here, just like with regular long division, we subtract at this step, and that's usually where students make a mistake in this, is that they forget they have to subtract. So anyway, 2x cubed minus 2x cubed cancels that first term, which is why we chose the 2x, so that that first term will cancel. Then I have negative 5x squared minus negative 6x squared. So that's the same thing as adding the 6x squared. So it will be just x squared. Now, negative 12x, essentially plus 8x, would be minus 4x. And then just like with regular old long division, we bring the next term down. And we repeat our process. So what do I multiply x squared to get x squared? Well, that's just 1. So 1 times x squared is x squared. 1 times negative 3x is still negative 3x, and minus 4. But I will be subtracting these two polynomials so that the first term cancels. This would result in negative x, and this would be 9. So what I can say then is that this could be rewritten as 2x plus 1 plus negative x plus 9 all over the original denominator, x squared minus 3x minus 4 dx. And this is called a mixed rational. And the reason we call that a mixed rational is that it's the sum of a polynomial part. Think of that as kind of like a whole number, plus a proper rational. I should call that a proper rational. Okay, now the nice thing about that is the polynomial, if we needed to integrate it, we could just do that very easily. In fact, it would be x squared plus x. Very simple, just use the power rule. Now, if we wanted to integrate this part, well, now here's where you can see the process of partial fraction decomposition coming into play, because this actually does need to be decomposed. So we would start with the decomposition of that. So I have, this is different work here, so negative x plus 9 over, let's see, that denominator would factor x and x, 4 and 1. If the 4 is negative, that would be great. So this would be a over x minus 4 plus b over x plus 1. All right, now if I go through and solve this, this would result in negative x plus 9 equals a times x plus 1 plus b times x minus 4. And this should be fairly straightforward to solve because I can choose strategic values that will make this pretty easy. So if I let x be negative 1, so this would be the opposite of negative 1, which would just be 1. So 1 plus 9 is 10. This term would cancel, and I would have b times negative 5, it looks like. So that b is negative 2. And if I let if I let x be 4, then negative 4 plus 9 would be 5. That would be a times 5. This term would cancel, so I would get a is equal to 1. So that means I can rewrite this integral as 2x plus 1 plus, so it's the form a over x minus 4, so 1 over x minus 4 plus b over x plus 1, so negative 2 over x plus 1 dx. And I can integrate. So as I said, these polynomial pieces will just integrate using the power rule. So 2 times x squared over 2 would make x squared. The integral of 1 is just x. This is the natural log. It's going to be the natural log of absolute x minus 4. And then minus 2 natural log absolute x plus 1. And let's not forget the plus c in the end. And let me make that a little larger so it doesn't look like 11. Okay, great, we're done. We have achieved what we wanted. Now, let's go through some questions here. Because sometimes students are jumping into these problems and don't look first that this original problem is an improper rational. Well, if that's the case, what happens? Well, actually, it's not that bad. What ends up happening is when you decompose this, if you use this entire polynomial, you will end up with this. So that's not a great, there we go. You'll end up with this, but you'll be missing these terms. Those won't be there. So you'll get, half the terms correct. You just won't see these polynomial pieces. So if you jump right in there, you'll just miss those. That's really it. I'm not going to go into the reasons as to why that's the case, but that's what will happen. So it's a little bit perplexing for students when they do this sort of thing and they see that they've got most of the answer correct, but then they're not sure where the rest of the problem came from. So just as a warning, that's what would happen. Now, another question. If all we're doing in this process of partial fraction decomposition is guessing at the form of the answer, can we guess at a form that includes the polynomial? Well, actually, yeah, you absolutely can. So if you wanted to decompose, let's see, it was 2x cubed minus 5x squared minus 12x plus 5. And I'll write this in the factored form. So that was x minus 4 times x plus 1. If you notice that the numerator is a higher degree than the denominator, then the difference in degrees would be by 1. Okay, so degree 1 is a linear. So you're going to end up with some linear term, but you just don't know the coefficient on that linear term. So you could guess it to be a times x. But that linear could also have a constant value. It might not, it might end up being 0, but It's possible. So it could be a linear and then plus some constant over x minus 4 plus another constant over x plus 1. And the question is, would this work? And the answer to that is, yeah, absolutely. This partial fraction decomposition doesn't only apply to just rational pieces. It applies to any type of piece of the problem you might run into. Now, solving it this way, is it going to be easier? Well, that's kind of up for debate. You see, the thing is, the more coefficients you have over here, the more work is going to be involved in solving for what those coefficients are. Now, if you have 4 coefficients and you can use strategic values of x for each one of those, it's probably not much more work to do something like this. But these terms here, ax plus b, they don't have any denominators that are going to cancel out these terms here. And so strategic values of x aren't going to work for solving for a and b. They will for c and d, but then you'd have to do the method of equated coefficients or some other method to figure out what a and b are. So by the time you go through all that, it's probably about the same amount of work as if you would have just done the polynomial division first and then used the partial fractions on the reduced rational that's left over. So it's not entirely clear as to which way is going to have more work or less work. But if you don't like polynomial division and you don't get right answers with polynomial division, well, this is probably down here a much better option for you. If you're pretty good at polynomial division, honestly, I would go with that, because the thing is, the values that you're plugging in, so this function here, negative x plus 9, is a lot simpler than this cubic that you're plugging in. You wouldn't need to grab a calculator. So I think the arithmetic is probably just easier in this step here. So overall, I would go with the polynomial division method, but it's entirely up to you.